My name is Joy Brake. My role here with the Maritime Link is it's called Integration Lead. And that's to ensure that the facility we've just commissioned, we've just energized and brought online, is going to work with the AC system on each side. So we've got Nova Scotia on one side, Newfoundland and Labrador on the other side. And when we connect this giant piece of technology, it has to work with both systems. Like right now, Newfoundland is a small island system. And if you put the wrong technology there, we'll black out their customers. So my role is to make sure, as integration lead, that this project is going to work for the benefit of both the people of Nova Scotia and the people of Newfoundland and Labrador for 30, 40, 50 years. It's really quite an amazing project that way. It has so many benefits.
Imagine.
Yeah, I'm gonna.
Feeling good? Yeah. So that was very interesting. So if I'm a person that doesn't know a lot about this, because of course you're very involved, in a simple sense, how do you describe, how this link is working? What is it in essence?
So the Maritime Link, it's a way to control the flow of electricity between both provinces. If you put a normal transmission line, like you normally see what we call an AC line, running between one part of the country and another, you have a limited amount of control. It's like water is going to run through it. If there's a pile of water coming through, it's going to run through that line to the other part of the country. If you put in what's called an HVDC link, we can control it. So we can say, we can take power from Newfoundland, but we can control exactly how much we take. So this technology lets us control exactly what we're sending and exactly what we're pulling from Newfoundland so that we don't do any harm to the customers in Newfoundland. The people in Newfoundland, if we pull too much energy from Newfoundland, their customers are going to lose their power. The lights will go out. So this type of technology provides very exact control. You can manage what we call voltage. You can manage what we call the power levels. So those kind of changes are, it's very important to manage that. Do we need me to start over on that sentence again now? Good morning, Rick. How you doing?
A little bit of a summary of, for the person, like a grade 10 class or something.
A grade 10 class. So, so the explanation I did before, were you okay with that? You followed, does that make sense?
I did. It just was interrupted just a little bit about the importance of not taking too much power from Newfoundland. Just explain to me a little bit again why that's important.
Okay, so the Maritime Link is a technology we call HVDC, and that HVDC allows us to really control the amount of electricity going to and from an area. If we could string an overhead line over to Newfoundland the same way as we have normal lines around the country, you don't have good control over the flow of power. When you use HVDC, you control exactly how much power you push or pull in a certain area. And it can be lightning fast. Like it's on, like we count time in milliseconds. A second is an eternity when you're talking transmitting power safely. So we can say we want you to pull 5 megawatts from Newfoundland, and it will pull exactly 5 megawatts. And you can't do that with other types of technology. Even if we ran regular AC cables under the ocean, we can't do that. So by having that exact control, we don't risk taking some of the Newfoundland customers off. Like we don't want to set in a power order that causes their lights to go out because we can't control it. This way we'll control exactly the amount of power and exactly when it's going to be delivered. And we can put settings on it so that if a generator goes off in Newfoundland, it will automatically pull some power from Nova Scotia so that their customers don't get interrupted. So it's a really fabulous technology that way. We got just really good control. Lots of benefits for both sides.
Sounds great. In my notes, I have HVAC, HVDC. You're referring to as HVDC. Is that the proper shorthand? Or what's the difference between HVAC, HVDC? Or is it just HVDC?
Well, HVAC is, we have AC lines that run all over the country now. Like if you go look at the substation out here on the side of the building, you see these lines going off the top of the building. And they go out like over to Tufts Cove where we have the big generating plant. So that delivers AC power to downtown Halifax for our customer. So that's AC. It's a traditional type of electricity. And the electricity tends to go where it's needed. It's kind of like pipes of water. If it gets a little bit low in one area, some will flow in, and if it gets a little bit too high, it'll spill it back out. And we're connected to New Brunswick and New York, right down to Florida. We're all part of one big system. So for that aspect, it works very well. It just ebbs and flows as you need it, and the generators respond as I flick my lights on. The generation automatically responds to meet that need. If there's say if a big power plant goes off, like when the nuclear plants, all the other little generators around the country just kind of come up a little bit, not the country, this section of the country, all the other generators come up a little bit and balance it back out again. When you're going over to Newfoundland, which is a very small island, you need to have much better control. They can't take the spill and you can't pull from them automatically. You have to have very good control on what's going to Newfoundland. So we use HVDC. DC is called direct current. That's like a battery. It's the difference between, I can't even think of what it would be like. It's like plugging something into the wall of your house or using a battery is basically the difference. AC is what comes out of the walls here. DC is battery. It's called direct current. It's like a straight line. AC is kind of like a pulsing current. It's a 60 hertz sine wave. So I'm losing track of where I was. Let me see.
Well,
I could go for days.
I think the point of all this then, so in terms of this technology, does it feel to you, is it kind of innovative and state of the art? Is this a special case that's being put into practice because of the particular challenges of Newfoundland and going across the ocean and all that?
So HVDC's been around for tens of years. It's called Classic, was the older style. You had less control. The facility we have here is HVDC, but it's also what we call voltage source converter. It's VSC. That is more innovative. It's only in the last decade or so that it's really taking off. And that's what allows us to have really exact control. And it works on what's called a weak system, which is a small system. And Nova Scotia is a weak system. Down by Cape Breton where it comes ashore, it's not that big of a system. So the technology we have, it's fairly new, innovative. We've added features here that set it apart from other links. Like we've got things here that's nowhere else in the world we've done them. Like the speed of the response here. In Newfoundland, again, small island, small load. If they lose a generator, you have to have response very fast or the customers drop off before the electricity reaches them. So we can have less than 100 millisecond response with the Maritime Link. So we've got two cables. If one cable fails, the power is transferred to the other cable, and it happens in less than 100 milliseconds. If it took a second, it's too long. It's too late. It's game over. We've already lost some portion of the load in Newfoundland. But by having that, anywhere between about 50 to 100 millisecond response, we can recover very quick if we lose one line. So that's the kind of things that we've integrated into this project that make it work very well.
That's very interesting you described that. Yeah, sure. It's very interesting you mentioned that there's two cables. All good back there?
Yeah.
Great. So all that described, should Nova Scotians and people from Newfoundland be quite happy and proud about all this? What do you think people should know about this?
The people in Newfoundland, Nova Scotia, I would expect, especially once we start to see the benefit of coming online, should be very proud of what's been accomplished. And in particular, huge amount of local talent has gone into building it. And one of the things I've come across and working with people from all over the world on this project is the talent in the Maritimes and Atlantic area is absolutely phenomenal. We don't know as much when we start about the specific technology, but we know our system and we know how to make the new technology work with our systems extremely well. We're very efficient, some very smart people floating around. And I'll tell you, I've come across some people that are just knock your socks off with how fast they adapt and they take this new technology and they're innovative in how they make it work with their system. And I think we've really impressed our contractors in some ways like that when it comes to being able to say, oh, that's what you can do. Well, I want you to look at this instead, and I want you to try this and this and this. And that's worked really well. The talent here is amazing, and the project is something that everybody in both provinces can take a lot of pride in. It delivers on what it's supposed to do, even above what we were expecting in the beginning in many ways. It's really a project to be proud of.
Wonderful, well said. In terms of your involvement, what kept you busy with all this? What did a day in your life look like when this was happening?
Oh, days of my life got to be extremely long just recently. So the last part, like we can talk about other parts, if you'd like to go there. But the most recent part of my role in the project is been taking it for a test drive, basically. We got a design in place. We work with both utilities, the power systems companies on each side. We got a design in place. We did studies. People came in. They built it. The construction had all its own challenges. We got the big line.